This is an ATIR, attenuated total reflectance IR infrared spectrometer. This measures the IR of a sample at this little dot right here. This is a small, very compact instrument. There's an IR beam bouncing back and forth in it, and a couple of key features about this thing. It has an anvil that can be tightened down onto the sample. You'll hear a click. You can also move the anvil out of the way to clean it. The first thing you should do anytime you're going to use this instrument is clean it. You should take a drop or two of ethanol, a Kim wipe, and gently clean off that surface right there. You're going to wait for that to dry. Any solvent such as ethanol, acetone, etc. is going to have an IR signal. And then the next thing you're going to want to do is clean the tip of the anvil as well. And what I like to do is take a Kim wipe, you can use the same one even, get that a little extra wet and just clean that tip. Make sure you clean that spot so there's nothing on the surface of that little diamond there. And then you're going to close this up. You're going to make sure everything's dried. Blow some air over it, wave your hand, do what you have to do. Close this down until you hear a click. And then you're going to open up the Omnic software. The Omnic software is going to be the center icon on the computer. Here's the software. It'll load up. It'll give you a warning. It'll have this help window. You can just close out of the help window. And then it's going to say accessory inserted, the ID5 ATR. You're going to click OK on that. I generally like to run these in expanded view so that you can see everything a little bit more cleanly. And so the next thing we're going to do is we're going to have to collect a background sample for this IR. And the way to do that is there are 3 buttons on the left side. Experimental setup, collect background, and collect sample. So we're going to ignore the experimental setup that's already done for us. We're going to go right to collect background. We're going to click the collect background button. And it's going to give us a prompt that says, please prepare to collect background. You're going to click OK. And then what this is going to do is it's going to show you the IR spectra, but we actually haven't started collecting the IR spectra yet. We're going to have to click on the Start Collection button right over here, and what this is going to do now is it's going to collect 16 scans from the IR, and it's going to average them to make sure that we don't have any impurities. So all of this is atmospheric noise. This is carbon dioxide, this is water, and we're going to zero all of this out so that everything along here is essentially at 100% transmission. You're going to, at the end of the collection for the background, you're going to have a confirmation. It says data collection has stopped. Do you want to add this to window? I generally say no because we don't need to know what the background looks like. It's going to make our further analysis a bit more confusing. So I'm going to click no, and this background will disappear. Now that we've taken the background and it's disappeared, we are now ready to put our sample on the instrument. We are going to unscrew the anvil. We will move it to the side. And the nice thing about ATR is that it can do both solid and liquid samples right on that surface, which is important to clean it between uses. So I have a sample here of isoborneo. I'm going to use a glass pipette, and I'm going to get a very small sample. There is a black dot in the center. That black dot is a diamond plate. All we need to do is cover our sample on that black plate. We then move the anvil back into position and tighten the anvil down for 1 click. Now that we have our sample on the instrument, we can collect the sample. The 3rd button on the left, we will click that button. We will type in our name of our sample, isoborneol, and then Professor Pemberton, click OK. It'll give another confirmation. Please prepare the sample. The sample's already been prepared, so we can click OK. And again, this is going to scan over everything. Notice how our baseline is pretty flat along the top. We have our single bonds over here. We have some SP3 CH stretches between 3000 and 2700, and then we have this alcohol stretch right here. We're not actually collecting our sample yet. We actually are just looking at the base, the background, or the initial scans. So we have to hit start collection, and that start collection is going to scan and average 16 samples so that we have an improved signal to noise ratio. This only takes a few moments. You'll notice here on the screen there will be a background age the last time the background was collected. I recommend collecting the background between each sample just in case you didn't get the instrument totally clean from the previous turn. When we have our sample collected, we will add this to the window. If you do not add this to the window, you'll need to rerun it. So we'll add this to the window, and now we have our sample here. And a couple of things we want to be able to do. We want to look at the peaks, because the peaks and the wave numbers for these signals is what we are concerned with. So we can hit Find Peaks, and we're going to come up with a new window here. This new window will allow us to click this vertical line. If we click it too low, we will not select a single peak, and if we click it too high, we'll select every single peak this thing can find. So we want to just collect maybe a few of these key peaks. The alcohol peak, the CH stretches, and maybe some of this stuff in that fingerprint region. So now that we have this, we want to save this image. And there's a couple of ways to do this. We can go up to File and Save As. Oops. We want to hit Replace. Apologize for that. So we hit Replace, and now we have our peaks listed on our spectra. So we can go up to File, Save As, and we can save this as a TIFF file. A TIFF file, TIF, will be useful in a Mac, PC, Google Chromebook, any sort of software will use a TIFF file. Some of these other files will not be readable. So you can save it as a TIFF file. You'll then give it your name, your title, and then save it to a flash drive. The other option is, and this is my preferred method, is to hit print screen on the keyboard. It is just to the right of the F12 button. So you can hit print screen, and this will create a screenshot of your IR spectra. You can go into WordPad. You can then copy that screenshot over, and then if you go back in to Find Peaks and then click on the clipboard option, the clipboard option will then save each one of these peaks, and you can paste your peaks and the intensities next to them so that you know where everything is. We're not done yet. The last thing we need to do is clean the instrument, and we do the same thing that we did at the beginning. Okay, to clean the instrument, we do the same thing as we did last time. Make sure you use a clean Kim wipe. You're going to unscrew the anvil. You're going to, with a bottle of ethanol or acetone, something that is a volatile solvent, that is a good solvent, you're going to clean both the anvil and the surface. And just to make sure that it's extra clean, we'll do that one last time. And a good visual cue is that your Kim wipe is not yellow or gray or green or brown. And then you let the instrument sit like this for the next person to use. One bonus feature that is often overlooked on this software is that it has the ability to search for that compound. So if you've created something and you're not quite sure what it is, you can search for it. And it will come up with a list of names. Now, this isn't always exactly correct. We have methyl alcohol on here. We have nisatin on here. And so unless the molecule itself, like isoborneol, is already saved in this library, it will not appear. So we can take something like methyl alcohol and overlay them, and you can see they're not quite the same spectra. But this does allow you to explore the structures that you may have made to verify them or to disprove them. And it's something that we really don't talk about in this class. And again, you can save the overlaid spectra by just going to Save As and saving it as a TIFF file.